Hello, and welcome to the solution of fourth challenge from Flare 2020 competition. This time it was called Report. As usual, we do get our note, and this time it reads: nobody likes analyzing infected documents, but it pays the bill. Reverse this macro trill right to discover how to get it to show you the key. And of course, we do get our report, which is the main file that we need to analyze. So I don't have really much experience analyzing Excel documents, so I didn't really know where to start, but I knew that this VM that I'm using, the Flare VM, contains some tools to extract information from Excel documents. So this is where I headed first. So I found this OffIceVis, which actually can open the file and parse it and gives us a bit information about the structure, and we can also saw the raw file contents. Didn't really get much out of it except for this particular part that was really standing out as a not really random. For sure it looks like something not random here being, but I didn't know what it is. What I was also doing was trying to use this OfficeMalScanner, but even with like a scan or even deep scan, it didn't really give me much information. I guess it detects if the macros are being considered malware and not actually give the macro to me. And this is actually what I wanted. I wanted to extract macros to have a look and analyze them and I guess get the flag. But whatever tool I used, I tried to even look on the internet, didn't really help. So for the moment I switch and try to analyze this file manually, like in this hex editor. And I also noticed this strange data here, which was visible in the OffIceVis tool. But I also noticed the PNG header data. So I thought maybe the image is inside this Excel file, and if I extract this image, I will get the flag. So that was my first approach. Unfortunately, it was wrong. Nonetheless, I did wrote simple script that would extract parts of this PNG file, because the file was really put in the chunks. So I had to take those chunks and combine them into the file to get the full picture. And I managed to do it, but unfortunately it was this image that is commonly seen in the files, to actually make sure that user will click enable editing and enable content and their macro will be run. It's kind of funny that this is Word document picture in the Excel file. I don't know if that was part of the challenge, but that was a bit funny to get into this file and finding out that approach was really wrong. So I took a step back and again try to find a tool that will allow me to extract the code. So I managed to find the tool, but I was a bit surprised because the tool name was called Pcode to Code, which from the name I thought it will just convert the code from Pcode, which is how the code is stored, to VB script. But actually it did extract the code, so it could extract Pcode and also code from this Excel file. There was some error when trying to run this tool, but nonetheless the code I could extract with this tool. So that was the first part of this challenge, extracting the code. Having the code, I needed to analyze it and understand, and of course get the flag. So the file with the scripts are not that long. There's like a 227 lines. We can see some issues with extracting the code. Still, we will be able to get the flag even with those problems here. So let's just quickly go through what this code does. So at the beginning we see, okay, that we'll run this folder OL function when the workbook opens or on auto open. So we can actually move to this function and see what does it do. And it just declares some variables and then splits something which we don't know yet by the dot and put it into this onzo variable. Of course, the names are really not meaningful. I guess they're also not that obfuscated, but we don't know what this onzo is. But we know that it gets value by splitting something which you also don't know. It's not defined in this file by the dot. And then the internet is checked and we see similar calls. The comments are mine, so they were not part of this file. We see onzo with the number and then this rigmarole. And onzo 7 is just accessing index of an array. So here when we split the value, we'll get an array, and here we'll just access the 7th element. I think in VBA it's 1 based, so it's like 7th element of this array, and we'll pass this to rigmarole function, which we don't know yet what it is, but first we need to, I guess, find out what this is. And I don't know how should it be correctly found what this is. How I did was notice when I analyzing this file in the hex editor and the information here that it has to be splitted by the dot. When I was analyzing this file, I noticed that this big data of non-random values, it's actually 2 parts data. So here we can see there is a dot every so often. So the values are divided with a dot inside and and it ends here. And the second one, it actually, there's no dot. So my assumption was that, okay, this is this FL because I have a dot here. And basically it makes sense to have this value be splitted by a dot, and we get those entries in each of the indexes of this array. So I just copied this value to a Python script. So this is value copied. I splitted it in by a dot. And then I have this rigmarole function, because as we saw from the code, each value from this array is put to this rigmarole, and then it is used for something else. So like get object, exec query. So the assumption was that this is like decoding some values from this encoded form, and this rigmarole function is actually responsible for decoding encoded values to something that we can read. And as we can see, this returns strings, so the assumption is that those are encoded strings, and this function is actually decoding them. So I just mimic the same function here in Python. It's not very complex, so it just takes 4 characters, split them by 2, and convert them to integers and subtract one to the other, and then just appends a character based on this value. And I'm just printing everything here. So if we just run this, and I just need to go to solution folder. So if we run it, we got those strings like updata, some mp3, play, flare on, sorry, this machine is not supported. So basically strings. We do get the strings values, which are used then later for the functions that we saw in the code. And this is what I did here with those comments. So basically this is error, this is this win empty, root, and so on and so on. Those strings are being extracted. It's like flare on, sorry, and again flare on, and sorry, this machine is not supported. So this onzo and rigmarole is responsible for decoding strings. But how the flag is extracted, or how it is hidden in this Excel file. So if we analyze more of this file, we actually get, okay, that the user domain should be something, but we don't care because we won't be running this script. But we can see this wabbit, I guess this is correct word. We see this canoodle f.t.text, some value, some bigger value, and the buff. And then there's like an environment with some more strings being concatenated. Actually, I didn't even manage to write what those values are. But this looks like yet another value that we don't have access here, like this FL here. So I guess it is something else in this Excel file, and we get the text, we provide some values, and yeah, we create some data out of it. So if you look at this canoodle function, it's yet again a function that actually decrypts the data from the values. And my assumption was that this value used as this f of t is the other data that was seen in this Excel file. So as I mentioned, we have this which is divided with a dot, but there is more data here that looks a bit different, and it doesn't have this dot in between, and it's much longer than the previous one. And that was assumption that this is somehow encoded flag in some form, we don't know yet. And this canoodle function with those parameters decrypts or decodes the flag to this wabbit variable. So again, canoodle, we have a function that it takes data, it just goes through 4 values at a time, and there is some kind of XOR function from the Bibble, and Bibble is also something that it's passed here as a parameter. So again, what I did was just to move this function without even a bit of analyzing. Of course, I had to analyze what this cbyte mid means. I just move it to Python, and I have the function here with the call, and this data is from the file, so it's quite long. As I mentioned, it's a lot of data. The name of the keep the name of the argument so that it's easier to just convert them. And yeah, it's just like taking values from this, from the first argument, which is this string, convert them to int, XOR them by the character in this Bibble. And do we have even more? I think it's just that, and then append to this variable here, and that's all. And the buff was flare on reversed, so I think that was also in this script here. If we just go to analyze, where we so this is a canoodle called with buff, and buff is generated here, and I guess if I remember correctly, this is like reversing this string. So that was maybe only one thing that had to be analyzed a bit more to understand, okay, this is like reversing the string of this flare on. And the flare on, I guess it's grok user domain, and yeah, if it's not flare on, so here is like comparison. If the Firkin is not flare on, we will just print that sorry, this machine is not supported, and we will end. So assumption is that it has to be flare on, and here we reverse to the buff, and buff is passed as a parameter to canoodle. Yeah, so we have the function, we have all data, we just need to run it, and it's stored to this flag PNG file. So let's just try to run it, see if it works. Solve free PI. Yeah, I don't know what does it actually print. It's prints the length of this data, but it's safe in flag PNG. So if we open flag PNG, yes, we actually managed to decrypt this file, and yeah, we have nice giraffes, and it says this could have been bad at flare-on.com. Yeah, so that's it. So actually that was all it was in the fourth challenge. Kind of fun. As I said, I didn't have much experience analyzing the Office files, so it was quite fun, learned a bit, and I hope you did also. So if so, please like and subscribe, and see you in the fifth challenge. Bye bye.